Well, hi, everyone. I'm coming to you live from the center of the internet here in Ashburn, Virginia. I haven't been here since the beginning of the pandemic, and I got to tell you, I'm blown away by the growth. If you haven't been to Data Center Alley, you really should come check it out. It is incredible. And I'm really looking forward to today's session. We have some great information and discussions to share with you. As always, I want to remind you that everyone here, we leave our companies at the door and we connect as individuals. We also need to adhere to our company policies, including non-disclosure agreements. The participants today are sharing trends and insights, but they are not associated to them individually or with their companies. They're sharing the content that we've been capturing over the last couple of weeks. We appreciate the contribution of all of our members, want to ensure that we can keep these insights continue to flow in and be shared with you. So make sure that you think about that in each of the conversations. And we have Chat Mouse rules. So what stays here, what happens here stays here within the member side. But the key here is that we're sharing content for all of us to really to connect, grow, and give back. So we're going to be kicking off with some work I've been doing with Rob Aldrich. He's the chair of the Sustainability Committee, and Eric Massanet as well, to define the industry's baseline capacity and consumption. So we'll talk about that in a second. Next, we're going to be doing a quick intro of the first draft of the recently released sustainability framework that's been developed by the iMasons Sustainability Committee, and to provide an industry best practice on the life cycle of a data center, a sustainable data center. And pardon me for a second. Goodness. Then we're going to jump into a panel of track leaders from our recently completed end user forum. That includes data center, network, hardware, and infrastructure management. These are awesome sessions. It's our second, third year of doing this, and just some incredible content. And then finally, we're going to be concluding with a virtual magic session. Yes, that's right. We're going to have virtual magic. I've had the pleasure of seeing Shimshi perform previously, and I guarantee this is going to be an awesome experience. He continues to blow my mind. I don't know how he does magic over the internet, but trust me, when you watch that, you're just trying to figure out exactly how exactly does this magic work. So everyone is going to participate in this. So just a reminder that you'll want to have a deck of playing cards available for you. Okay, and you need to make sure that this deck is okay to be torn up. We're going to be bending them and cutting them and tearing them in it, but everybody's going to be participating within this. So you'll be picking 4 cards at random. I bought this deck last night for this very thing, and it's going to be a lot of fun. Okay, so let's get started. I'm sure all of you have heard the wild predictions of capacity consumption by the data center industry, quote unquote. This has been really frustrating for myself and many people inside of our industry, as it changes depending on who you talk to. So Rob Aldrich, Eric Massanet, and I took on the task to help define it and really get a starting point for the industry baseline. So some of you, some of the content that we've created in the structure and the framework may seem a little controversial and will need more member input. We believe, though, that this is the type of thing that will set the way that we approach this, that's going to be consistent and allow us to be able to have a starting point, to be able to collect information and start to show progress against that. So with that, I want to go into the first one. For us to be able to have an industry baseline, we first need to define exactly what digital infrastructure is. So the term data center is incomplete. It only defines a portion of it. We need something holistic. So we decided to keep this simple. What is the very basic function of digital infrastructure? So digital infrastructure is a collection of data center locations that deliver electronic services to people and machines. So think about the words in that. Digital infrastructure encompasses everything that allows these devices and machines around the world to operate. So those go through specific real estate locations, data center locations, and in those locations, they're doing electronic services. Now, electronic services is all encompassing as well. Simple words, but they are serving people, 8 billion, and machines. The machines themselves, by 2030, are going to be 130 billion. We're going to have a lot of stuff connected, and the digital infrastructure is serving all of those connected devices and people to be able to actually operate. So first we started with the definition, but the next thing we need to do to make it useful is define exactly what a data center is. So data centers are real estate locations that house IT equipment, and they do 3 things. they process the information, they store the information, and they transfer that information. So again, everything that you do, whether it's a banking transaction to watching a cat video to mining Bitcoin, is going into some location to do that work. It traverses a network and hits a whole bunch of points along the way. So the main thing here is that every data center will have a real estate location, and that means it has a unique address. Doesn't matter what it is, where it is, there's going to be a unique place that is for that location. And that allows us to be able to now start to track some things. So again, digital infrastructure is digital services that are delivered to people and machines. Those data center locations that enable that house the equipment to actually complete it. And they do one, two, or three things. They process and store and transmit that data. But for us to understand, we need to also classify what data centers are. So we've come up with three categories that make up data centers in digital infrastructure. So we have the first bucket, which is called providers. And that's the only word I've been able to come up with so far, because it does include colo, cloud, edge, hyperscale, enterprise. Basically, anybody who's providing the service to others or providing the service to themselves or a combination thereof. It's all the infrastructure around that to allow that provider to do what it needs to do. But that's basically the data centers that are out there for that provider to serve. But then we have another category, which is network. That's everything from the mobile networks to the fixed networks to the carrier hotels that allow all this connectivity and internet exchanges. So the network element of itself is different than the providers. We're trying to classify these, and you'll see what I mean as you see this paper come out. And then the third category is crypto. And this is controversial. People are saying crypto isn't a data center. It doesn't use any UPS or generator. It doesn't have any kind of technology that we will throw back into regular data centers. But if you look at the definition, it is doing digital services. It's using blockchain to allow the calculation of hash rates to be able to now have cryptocurrency created. So all of this is still encompassing digital services. And the reason we had these three categories is we couldn't do a measurement of a subset. Digital infrastructure is all the things that are providing those services for people and machines. That includes crypto. And if you look at the way that this actually now allows us to measure, we can set the baseline. So if we go to the next slide, how big is the digital infrastructure? Right now we have 7 million unique data center locations. It was 8 million last year. Lots of consolidation back into cloud and to other colo locations, but there's 7 million data centers. There's 104 gigawatts of built capacity. That is consuming 594 terawatt hours of energy around the world. And that represents 2.4% of total energy consumption globally. Now, I want you to think about this for a sec. Based on that methodology we just did, we said there's 7 million unique locations. They have 104 gigawatts capacity built in those unique locations, and they're consuming 67 gigawatts of that 104 gigawatts. That represents this growth or this actual consumption around the world. Now, once we have that, imagine every location has a unique address. It has a classification, still could be one or two of those different categories we said. It has a unique source of energy, and it will be able to get the carbon mixture. If that starts to report back up, we can have a real-time measurement of digital infrastructure consumption and its carbon footprint. I think that's the most important thing here is if we do not have a standard methodology in which we can approach that, there's no way we're going to have a defensible number for us to be able to show progress against what we're trying to do. So my goal here with this presentation is to just plant a seed, get you thinking. What exactly is digital infrastructure? Is it all encompassing? Are these categories correct? Are we really actually going to be able to have a baseline? Because if we can do that, we can take control of what we're trying to get done when it comes down to digital infrastructure and its contributions to society. Okay, seed planted, watering, let it grow. More on this to come on local chapter meetings and other global member summits, as well as the committee meetings we're going to have. Okay, so we're going to go on to our next topic. Recently, the first draft of the sustainability framework was released by the Sustainability Committee. And joining me is Svein Hegeseth. He's one of the Sustainability Committee members, and he's been driving this work from the beginning. So Svein, great to have you on here.
Thank you very much, Dean.
Great. And where are you joining us from?
I'm actually joining from the air. Oh, that was interesting. Just a second.
From the ceiling.
Just a second. He doesn't want to give me the front.
There we go.
Excellent. Hi, everyone. Yeah, I'm joining you from Oslo, Norway today.
All right. In Norway. Great. The Nordics. Wonderful. Well, Svein, we're just going to take a few minutes. And again, just like we did with the industry baseline framework that we're putting together, you guys have been doing a lot of work in the sustainability committee to come up with a way in which we can have a holistic life cycle view of the data center, right? From a sustainability standpoint. So why don't you give us a quick introduction for people to get an idea?
Absolutely, more than happy to. So as we all know, sustainability is becoming an ever-growing topic of interest, and also a concern for the data center industry as a whole. And this is something that is driven both within the hyperscalers and global enterprises. And there's a continuous drive for kind of a sustainable future, a carbon neutral future. So we have tried to look at or identifying different type of frameworks that can kind of constitute what a sustainable data center actually is, and how we kind of can define that in a good way. So when we started looking at this, we probably found 100 different initiatives in regards to carbon neutrality. And as part of the vision of every click improves the future, we wanted to kind of define what a sustainable data center actually was and how we can kind of measure and also motivate clients to kind of start on the journey. So if you look at a hyperscaler, they're maybe 90% on the way in regards to achieving sustainability and carbon neutrality, or at least have a journey to get there. But in many territories around the world, it's harder to go sustainable. So the ability to kind of share those best practices and how we can kind of make sure that you both have a framework on how you can measure that, but also that you actually get the help that you need to be able to get to those best practices. So we created kind of cradle to grave sustainability framework that kind of goes from whenever you started to plan a data center and how you kind of think about sustainability from that perspective until you actually decommission the data center on the other side, or hopefully never decommission the data center, because we all know that that it's better not to build.
Adrian, can you go to the next slide? So as you start to explain this framework so people get an idea, you said cradle to grave, basically from the start to the right. So the creation of it to the actual retirement of it, correct?
That's correct. So we wanted to kind of create a model that includes kind of a life cycle approach, kind of a holistic life cycle end-to-end approach. And that we kind of have some, so this framework is kind of this objective of what makes it sustainable. And then we, within each of these areas, so for instance, if you're looking at the pre-op phase, you have strategy, design, build. There might be other type of things that should go in there as well. But within each of these different topics, you kind of have a checklist of simple questions that could be 10 in one area, maybe 100 in other areas. There will be sub-chapters within the different checklist to make sure that people kind of, and they will be simple. They will be yes and no type of answers. Mm-hmm. Have you, are you acquiring sustainable energy through PPAs or X, etc.? Or are you green 24/7? Are you recycling your waste? What are the degree of the recycling, etc.? Are you reporting on emitted?
Looks like we lost Svein. Okay. All right. So let me fill in for Svein a bit here. This is really a methodology. The methodology here to be able to have end to end. And just want to make sure, Adrian, can you hear me still?
Yep.
We're all good. Okay. We just
we just lost him.
We lost Oslo. Okay. All right. So just so people get an idea here, the Sustainability Committee really took this as output from the launch of the sustainability vision. Every click improves the future. Part of that was defining a sustainable framework for data centers. And this is think of it as step one. Now we spent the time to go back and define these different areas, but it is the pre-operation to the operation to the post-operation. Pre-operation, how are you designing the data center? Where are you sourcing the parts from? Is the embedded energy in that data center actually collected? What's the efficiency that's expected? So just think of checklists on that one and you'll be able to report back up. Then there's all the things that happen in the data center that you operate. Where are you getting your energy from? What's the efficiency? Are you achieving your design day parameters? How are you doing automation? And there's a whole bunch of elements inside of that. And then are you going to be sharing the information that you have on that? Energy consumption, utilization, efficiency, just like we said within the industry baseline. Then once you are now getting to the post operations, what happens to everything in that data center afterwards? There's all the embedded carbon and those the actual retirement or the disposable equipment, et cetera. There's just a lot of elements around that. And so the point of this, hey, Svein, welcome back.
Hey, sorry about that. I was thrown
The
out.
internet, you know, hey, there you go. No problem. I filled in for you. I'm just giving my perspective here because in the end, this methodology is for people to really get their arms around what is possible. And if you look at the levels on the bottom, this is really driving towards really transparent visibility about what you're doing, how well it's going, right? And getting to a higher maturity level when it comes down to sustainability in the data center. Is that correct?
That's correct, Dean. That's the whole objective, right? So,
okay.
Like I said, the ability to kind of make sure that people actually can measure the progress on how when they're implementing different type of measures, that you actually see your improvement score in that assessment. And then of course that we all have the ambition to become a value-driven data center, or all our data centers to be value-driven.
If you look at the next slide, the whole point here is that you're continuing this methodology. It's a maturity framework. As you start to report these things out and really understand it, you're just getting to a more mature, sustainable data center itself. And look, the key in this is that we're introducing the concept, right? The sustainability committee spent a lot of time on this, lots of different chapter meetings, input from different people, but it's step one. And now that it's out here, this is what we want from this community. Correct, Svein?
Yes, we would like to have a kind of a call to action for the industry as a whole to make to help us fill this framework, right? Mm-hmm. Because even if for many in the sustainability committee, we don't have all the answers, we don't have all the kind of experiences, so we need to make sure that we invite the whole industry to fill this framework with these questions that within these different topics, and we all have different kind of expertises as well. So some providers might be good in one area but bad in another, right? So the ability to kind of call on the whole society to help us.
Yep. Awesome. And thank you very much, Svein. First off, I appreciate you. You've taken this ball and run with it, continued for like almost a year, if I remember correctly, right? And so anyways, there's more work to be done, but for everybody else, we're going to be having local chapter meetings. This is one of the topics we're going to be putting out there to provide input on. This is the whole point of Infrastructure Masons, is to connect, grow, and give back. We're collaborating on these contents to be able to now do it. Some of the elements within that framework may change, the definitions, even the titles may change, but the point is we're aligning on what that methodology is so that we can now make progress towards being able to measure this consistently. Great. Okay. Thanks, Svein. Appreciate it. All right.
Thank you.
We're going to move on to our next topic now and get into the meat of the end user forum. Pardon me. This is killing me. I'm not sure what's in my throat. A few weeks ago, we gathered over 100 digital infrastructure end user executives from all over the world. All of them are grappling with different challenges in their businesses, but they all seem to have very consistent themes across the challenges they're facing. So we hosted 5 two-hour technical track working sessions. This is across data center, hardware, network, infrastructure masons, and infrastructure management, as well as our partners coming in to provide insights into the challenges and things that they're seeing. So the attendees left their companies at the door, and of course, they shared what they were facing. And in these sessions, we usually ask one question, and time just flies right by. That question is, what's top of mind for you? What are you facing? What are you seeing? And the following week after those track sessions, we brought the different track chairs together in the end user forum, and we talked about more of that information. And those track sessions, they shared what they learned. And so what we're going to do today is we brought all of the different track leaders together to talk through those trends and those things that we're seeing. So I've invited the chair of Mesos track to join me today, and I'm joined by Gene He from Uber, who led the network track, along with Jason Black from NVIDIA, Kurt Belisar from Apple, who led the hardware track, along with Ashvini Mangala-Vedekar. I almost got it right that time. And she's from eBay. Deborah Vieira from Facebook, who also led the data center track, along with Dave Wildman from Bloomberg. And Ketan Kahatri from Uber, who led the infrastructure management track, along with Wendy Pfeiffer from Nutanix. I got to say, this is quite a powerhouse panel of people we've got here. So welcome, and thank you for joining me. So we're going to go back into the panel view on this one, and let's see if we've got everybody on. All right. Okay, Kurt, you're up in Yosemite, it looks like. Ish. There we go. Okay. Well, first off, I introduced you guys, but can you just tell me what part of the world you're in, and then we'll jump in. So, Kurt, let's start with you.
Sure. So I led the hardware track. So I lead a team that develops hardware, server and storage hardware for the hyperscale space. And we deal both with aspects of the system hardware and aspects of how to integrate that into the data center.
Awesome. Awesome. And you're in the Bay Area, but you also are in Texas too. Is this
That's right. I'm in spirit. I've got the Bay Area picture behind me. That's actually down south of Big Sur. And right now I am in Texas.
Excellent. Okay. Deborah.
Yeah, I'm in Oakland, California right now.
Excellent. Okay. And as far as the scope, what you handle over at Facebook?
Right, so I'm in the facilities engineering team, and so we're a division of the facilities operations team. So really making sure that our fleet of data centers is up and running. So that's the focus.
Got it. It's a little portfolio, right?
Just a small one.
It's a small one, yeah. There you go. Gene.
Hi, good morning, everyone. I am located in the Bay Area, California as well. I am a technical lead in the global network infrastructure team at Uber.
Awesome. All right. Ketan.
Thanks, Dean. My name is Ketan Kahatri. I'm also in the Bay Area in California. I lead a team responsible for business operations that encompasses capacity management, fleet operations, financial management, alike. Within Uber infrastructure.
Excellent. So what I love about this panel is each of you have a different vertical that you focus on, but these are all very large problems when you think about hyperscale and you think about global delivery. And so, and then you assembled all these different folks together who also came from over 71 different companies. And you just think of any brand out there, and we've had representation from those companies in these tracks. So first off, thank you for your time. I know it's precious, and you gave it to us, and we really appreciate it, both at the actual track sessions as well as today. So what I'd like to do is I'm going to give you each a chance to talk about kind of the key elements that you learned within the track itself. And then I'd like to have an open discussion about those things, because there's definitely overlap that we saw, some trends across these different tracks themselves. So Kurt, I'm actually going to go back to you as well for this first one. So from the hardware perspective, give us your insights. What did the team learn?
Great. I'll summarize, because we actually had 3 separate groups that met, and they all had some similar themes, but then there were some different topics from each of them. So I'll try to cover all of them. First, I think it's obvious that COVID is something that's on everybody's mind, and that came up in a couple of the tracks. And it's just the things that were discussed were, one, how has it affected the work-life balance? How has it affected work in the workplace? There was some discussion about how do we predict that it'll change things, as we go forward. Will we come back into the office part-time? Will we come back to the office full-time? With some companies, it's going to depend on what kind of position you're in. So that was one of the discussions. There was also a discussion about how COVID has affected supply chain, and I don't need to go into that. I think we all can read about the headlines that are in the news, but we're all having to deal with a significantly different supply chain situation than what we dealt with a year and a half ago. And so I wanted to mention those and put those out there up front, something that's on everybody's mind before we got to some of the more pure hardware topics. As we started to transition into some of the things that are more classic hardware topics, one of the things that we saw that was a thread across multiple of these groups is just dealing with parts that are starting to become more complex. And I think a lot of people were thinking in terms of processors, so I'll start there. But we're just starting to see, more and more gates crammed into the processors. We're starting to see them dissipate, more and more power. And we're also seeing them released at this, it seems like this quickening pace. And so there was a lot of discussion about how to deal with that. A couple of the comments that were made, one was that as we start seeing parts that are more dense, and this was specifically with regards to memory, we're starting to see things like errors pop up in memory. We've always had soft and hard errors in memory, but the truth is that as the processes shrink, we're going to see more and more of soft errors in memory. So there was a pretty healthy discussion in one of the groups about how do you handle error correction and detection. And so far we've had these parts that have handled that very well. But what are we going to do going forward? And one of the discussions that came out of that group was that software needs to take a larger role in handling these errors. And ultimately, you may have to have software that is, locks up data that you're sending at one end and unlocks it at the other end and checks it. And, that may be the ultimate solution. Likely in the short term, we'll have both hardware, error correction and detection, and start to have to implement some of these software features. So that was one of the topics that came up. There was a lengthy discussion on that. There was a lot of discussion about how to handle the increased power dissipation from servers. It just seems like the power dissipation is going up as you have processor vendors, and in general, as we're starting to cram more and more into the servers. And so that was one where the team just kind of agreed on it. And there was some lamenting that we used to see these processor wattages that were under 100 watts, or even down in 85 watt range or less, that were designed for the enterprise. And we're not seeing that so much anymore. In fact, one of the comments was made is, geez, looks like the smallest part I could find going forward is going to be like a 24 core processor. And just think about that for a moment and think about where we've come from. And it just creates all kinds of issues in the data center. We've got to figure out how to, how do we dissipate the heat? We've got to figure out, is there going to be some ways to scale some of these processors down potentially, or request the ability to turn off portions of them potentially for applications that we want to have that don't need all of that, all the resources that we have. Another discussion that occurred that was healthy was around networking. And the comment was made that as we start to transition to, 400 gig links up and more, and then we start to see in the servers 100 gig NICs, how do we handle the oversubscription rate? I'll tell you where the comment or the discussion started was actually that the portion of the cost of a rack that is allocated to networking is increasing at a portion that is greater than the other portions in the rack. So if you can go take up a rack of servers, you kind of divide it up and you look at, okay, how much cost do I have in processors, how much in memory, how much in drives, how much in base chassis and motherboards. The portion that's allotted to networking seems to be increasing greater than the other portions. Or I think that one of the comments was made is that innovation in that area has not kept up with innovation and cost optimization in the other areas. So you're starting to have to see, or people are having to evaluate, can I stick with copper at all? Is there some strategy where I can stick with some of the slower NICs for some applications before I have to transition up to 100 gig NICs? When am I going to have to transition to optics? But point was made is that we're seeing the cost go up. There was, again, there was more of just a consensus discussion about it, and that it's an issue. Like you said, this was a topic that was top of mind. It's not necessarily going away. We seem to have applications that are demanding more and more bandwidth. At the end of that discussion, there was a transition into another discussion that occurred, and it was a discussion that basically asked the question, is composable infrastructure finally arriving? In other words, can we start to decompose a server into pools of memory, pools of compute, pools of storage. There were just some discussion about CXL2 as potentially being an enabling technology for that. There was discussions about predictions as to when this would start to make its way into the data center. And, we think first there may be composable pieces that you start to see within the rack. Later in time, probably years down the road, we'll start to see it where it'll spread, multiple rack. You'll be able to divide up components amongst racks or spread them farther apart. And there was a part of the thing that led into that discussion from the networking discussion is, will this be a thing that will bring more efficiencies, both in cost structure and utilization? And that's ultimately the thing that you hope for as you have a composable architecture. I think the last conversation that I'll point to is there's a discussion about offload processors and accelerators. And it was an interesting discussion. It honestly surprised me a little bit, but the discussion was how well are we as an industry making use of offload processors? And so the discussion was that, with things like GPUs, we think that the industry is doing very well. They're widely used in a lot of ways. People are, certainly figuring out ways to use them, and then having lots of discussion about, well, how do I deal with them in the data center? Those dissipate a lot of heat. How do I handle that? But as we start to look at some of the other offload processors that we thought had a lot of promise, it's almost like we've not found that killer app to take advantage of things like SmartNICs and some of the other offload processors that are out there. And it's not that there aren't certain instances where people are making good use of them. It's just not as widespread. And that surprised me, actually. I thought that you would start to see multiple companies that were saying, yeah, we're starting to really take advantage of these things to offload cycles from our standard CPUs. But it wasn't happening as effectively as you might think. That was the last topic.
Okay, and I started with you on purpose, Kurt, because if I look at basically digital infrastructure as a system, you think about all the components that go together. The most expensive element of that is the compute, storage, the other aspects of that hardware that's going in there. And then the next layer of that is the network that actually interconnects them. And then there's the packaging of that around the data center to be able to power and cool them, right? House them. And then there's the infrastructure management of that stuff. And so I want to go in that order, but there's a few things that were pulled out of there. And by the way, I think we're going to have debates about this because we saw both sides. You talked about their 32 cores is the minimum size on a chip. That chip is going to go from 100 watts back up to 250 watts. And like the densities of the devices are getting denser, both from a core standpoint, from a power standpoint, and now even from a network standpoint, as far as bandwidth. Everything's getting densely packed inside of that box. Correct?
Right.
And the result of that's coming out here is having to deal with the ripple effects on the network, as well as the cooling, right? And the power aspects of it, and then the overall cost of running that system itself. So, and then you also said the software part, having software that's going to be able to handle errors, but also having software that's going to be able to handle orchestration around these things. It's bare metal management, basically. And I know that there's a number of people on this call that deal with that, right, daily in the portfolio. But the trend that really is coming back, from what I understand now, is that the densities are increasing, the complexities are increasing, the error potential within those are increasing because of the density, chips and other things, right? But then the ripple effect is that wattage. Okay, and that goes back into the dense elements. Okay, so I want to go to Gene next, because you talked about the innovation or lack of innovation when it comes down to bandwidth out of those devices. You were saying that all the processing or offload processors, or not offload processor, you talked about the network itself going up is not moving as fast as the rest of the elements inside of the server. So before we go into Gene's thing, can you just explain that a little bit more? What is it that's actually missing?
With the networking in particular? Yep. Yeah, I think that we're seeing the bandwidths go up. I mean, there's certainly innovation where you're seeing bandwidths, double, and it's happening, periodically. But what's not happening is that the cost, again, this was really where the discussion focused, is that the cost of the networking in the rack
Mhm.
was going up disproportionately compared to some of the other components in the rack. And so, and then the question became, if I want to maintain some of the same oversubscription rates that I had with 25 gig NICs, I'm either needing a bigger switch or am I putting 2 TORs in a rack? There were discussions like that as well.
Mhm. Mhm.
So we know that there's going to be a need for more bandwidth. The innovation is coming to enable us to have more bandwidth, but it's going to become a larger cost.
Okay.
That's what the concern was.
Okay, and that actually really opened my eyes in the conversation on that track as well, because it just, when I looked at hardware before, it was the cost of the rack, then the cost of the network out of the rack, right? The fabric, the WAN, all the other aspects. But I didn't really think about, what about the NICs? Those are going up. What about the fiber, right? The optics, the other elements, that adds up. I didn't really think of it. That was all embedded inside of the hardware costs. But they're truly network costs, because you're saying how I get those things connected. So that's interesting. We might want to look at the breakdown, because in some of the past lives for me, it was 60+% of the overall cost of digital infrastructure systems was hardware.
Yep.
Right. But 20% was data center and 10% was network. But if you now open the aperture and look into the hardware, all of a sudden, how much percentage of the rack itself is network costs?
Yeah, I think
Just
it's
in the rack.
important to create that pie graph of costs all the time and track it and understand what the trends are. And it's very telling. This was one that caught me a little bit off guard as well with our discussion, but it's
cool.
happening.
And one topic I don't want to talk about right now, but just as we get through the rest of the folks, is that composable infrastructure. So keep that in mind. We're going to bring that back up, folks, because if that truly is a trend where we're taking these aggregated things and starting to disaggregate them across, what does that mean? What does that look like inside of what we're doing with infrastructure itself? Okay, Gene, I'm going to transition over to you. So give us your insights from the network standpoint. Feel free to comment on what we just walked through as well on the in the rack network.
Absolutely. Actually, I'm going to follow up on what Kurt was just mentioning about and talk a little bit relating with that comment on the networking side. That may be some of the additional info that can fit into that conversation. So we talked about 400 gig, for example, as Kurt mentioned, like the network along with the industry, it's definitely keeping an eye on as we're transitioning from 100 gig to 400 gig. However, 100 gig in a lot of the networking hardware domain are still making the most economic sense. And 400 gig SKU types and all the networking hardwares are still too expensive to be deployed in large fleet. And that may be some of the reasons, like if we embed a 400 gig based a top of rack switch into a rack, it definitely won't go proportional as how the previous 100 gig based top of rack switch was presenting. And so, but definitely as we are preparing for some of the innovation that could happen in a data center, like GPUs and all the machine learning driven data flow that could actually boost up the bandwidth utilization within the networking industry. The team and all of the networking various companies, engineers are preparing for those kind of innovations to making sure the network will be ready if 400 gigs become a cost-effective solution, and the industry has to be driven to move to a faster and a fatter network. And throughput still shows as existing how it's been consumed, that east-west traffic across the data center are mostly driven and heaviest flow that's happening in the networking side. And therefore, I think most of the companies are closely monitoring while preparing, but still have a large number production fleet-wide being in 100 gig. So that may be some of the related conversations to what Kurt was mentioning about. And in the networking track, as Kurt mentioned, we also have some of the similar conversation relating with the COVID, and it's definitely has large impact on both like people's work life as well as in the industry, that the supply chain see a lot of challenges, and it's still what people are dealing with on a daily basis. Like on the networking hardware side, we're seeing long lead time, we're seeing delays, and some of the team members mentioning that on a daily basis, they see the hardware is being sitting in the ships in the Bay Area, but couldn't be fully delivered. And all of these added on challenges into the network infrastructure built on the ground. People seeing that difficulties and a lot of challenges of bringing distributed co-locations or relatively large data centers for large enterprises. So these are, I think, a lot of the track also discussed and faced on a daily basis. So we will probably enter more conversations relating with this later. And so relating with that, on the other side, though, most of the participants mentioned in the networking track that innovation on the other side hasn't been impacted too much from the COVID situation. We're still seeing a lot of innovation happening. People are not discouraged or being impacted. Even in a lot of cases, people has to be remote. A lot of innovation are still happening to create new technologies and new designs and architectures in the networking infrastructure, and with the collaboration that more happening online and remote. So that is one of the plus side that people are seeing that.
And Jean, one clarification on that. So I think what you're saying is that inside of the teams, because network folks have been remote
correct
previously, so it really isn't something new when it comes down to collaboration. So internal teams, as they design and roll out and those things, the pandemic didn't impact it as much from an innovation standpoint.
Correct.
Yeah.
Correct.
Okay. Got it.
Yeah, that's more like the daily life and how people are already automating, especially for the parts that people have adapted to our process or the technologies that supports them to develop remotely. And that's actually a good call out, is that on the networking side, we still have quite an amount of people that are on the ground helping to build the network infrastructure within the data center. And they have to be there locally. So those are some of the challenges that people are seeing, that we have to find innovative and creative ways to how to help to build the data centers in the network infrastructure in the data centers in those fashion, and how it's been reduced the impact from the COVID. And also other innovative ways that has to be created, like how we address the supply chain challenges. For example, how we coping the long lead time, pre-ordering ahead of time, or finding multiple sourcers to making sure the procurement will be smooth and it won't be impacted too much. And those are also some of the innovative supply chain and planning that various teams are facing and trying to solve for. Another thing also popped up, similar to what Kurt mentioned, is automation. That's another topic a lot of the team mentioned. It's becoming a big part on the daily management as well as the build of the networking infrastructure. However, with a lot of the and people are seeing in the headlines and various teams experienced on outages relating with the automation, etc. People have realized that we still have gaps in building fully reliable, resilient, and very robust automation system to support our network infrastructure. There's still a gap that's still there, that a lot of the automation work has to happen to making sure that we have on the other side, a well-tested system, as well as have the right resources. For example, have either a very skillful software networking, a software engineer that are have very deep knowledge in networking, or have a network engineer that has very skilled software programming skill sets in order to support that. Because automation is very important for us to manage network infrastructure. We needed to understand about, for example, how network resources are being utilized, and also how to tuning and making sure performance efficiency will happen, and to aid to provide visibility on, for example, network resources happening not only on the network different layers and components in the data center, but also happening up to the host level, and see how the networking stack are running on host, and making sure the network performance are tuned up to the maximum to support various different type of applications or workloads. So those is also another big part that people addressed as a growing area, and both an innovated as well as a existing problem that various teams are striving to solve for. The last topic that we touched a little bit is security. I think many companies and parts has mentioned that network security is becoming more and more important part in the future for a team to making sure that our infrastructure are reliable, fully protected to against like DDoS, etc. Not only for on-prem, but also even if like you utilize some of the cloud environment, that is also a hot topic there.
Gotcha. And especially with edge and so many other areas, that the vectors, right? The threat vectors are massive, and it's just going to only get bigger. So yeah, security. And I think this goes back into the offload processors that Kurt was talking about. How do we do zero trust networks down to every element within digital infrastructure? How do you protect? Because you need to remove those threat vectors. One thing I wanted to touch on that you were saying in there is, I remember this whole, 10 gig to 40 gig to 100 gig and kind of the interim step with 40 gig. And so I was literally in a data center yesterday. I saw one of the switches that had a breakout, right, from a 40 gig to get 10 gigs to the nodes. And then I thought, okay, that exact same thing is now 100 gig to get 25 gig to each of those nodes with 4 of them. And I think about this 400 gig you're talking about. And there's a little bit of a conflict between what Kurt was saying and what you were saying, is that, it's too expensive to roll out 400 gig, but 400 gig at the fabric layer is where you're talking about it. But then there's also the machine learning and other things that require 100 gig or more at the node level.
For the NIC?
For the NIC itself. Yeah. And so you just wonder, is there going to be a leapfrog of it's like the 100 to 400 to terabit versus like we did with, 10 to 40 to 100 gig? Do you think that that's going to happen, or is 400 gig going to roll out eventually with good costs?
Yeah, that's a great question. I think right now, a lot of the companies that we have talked to on the network track haven't been seeing large driven bandwidth that are driving us to look for bandwidth that are higher than 400 gig in the networking side. And a lot of times that right now, the 100 gig based network infrastructure, even in the fabric, is capable of handling the throughput. And 400 gig, we're seeing only specifically being driven by the special workloads, such as the bandwidth heavy workload types, data, GPU, etc. And those don't seem to have been like becoming like a driven part of majority of the data center built yet. And so we haven't seen a lot of company even mentioning and starting seeing that the boost of being driving up to higher than 400 gig, and people are still looking at the 400 gig. Yeah.
Okay. So there might be a leapfrog, just primarily driven by price. But the other thing we're going to talk about this with everybody is the supply chain impact. So Kurt mentioned it, you've mentioned it. I'm sure it's going to be mentioned by others. And there's some interesting trends that are happening because of constraint, right? And it could be that you just wouldn't even be able to get the 400 gig hardware based on demand, based on shortages, and based on delivery. So yeah, interesting thing there. And then one other thing that I think is really important to pull back out is that the talent that you're hiring is changing. It's not just a network engineer. You're looking for a software engineer and a network engineer that's a hybrid, because they need to be able to now take software into that plane and drive that to be able to have scalable infrastructure and all the observability and monitoring and all the hooks, everything in there to make sure that you can automate the hell out of it. So that's software is going to eat the world. I think software is going to be in the minds of everybody, right? And what we're doing at every layer. And that includes data center. So I'm going to transition into Deborah here. And Deborah, you've been hearing this conversation. Why don't you start with your trends and feel free to tie in the stuff we're seeing, specifically around density, because I know you had a debate with that within your track.
Yeah, density, definitely. We were discussing what is high density for the individuals, or the companies in my group. And what we really came to is that high density was 20 kW or less per rack. So not really the high density that we hear out in the media and that is hyped up. In addition, the high density was not the full data center itself. It wasn't even a full data hall within the data center. It was just a small component within the data center, maybe 10% or less, or maybe even 5% or less of the full quantity of racks that we had in the data center. And then addressing the cooling for these, I'm going to call them higher density racks that we had. Most of them were being addressed with either sidecar racks that had cooling, and so it had a heat exchanger on it, and then there was liquid cooling to the rack, but that the heat was actually dissipated through the airflow in the data hall itself, so it wasn't liquid cooling to the data hall itself. There were a couple that had pilot projects where they were trying liquid cooling to the data hall to see how that went and what the maintenance implications were, the construction implications, and trying to understand that. But even as densities go up, we're not actually seeing it being utilized in the data centers just yet. Where we saw more effort around right now was utilizing really every watt of capacity that has already been constructed. Several companies had indicated that they were in a capacity crunch right now, and so a lot of their focus was on balancing hardware, balancing software across available components, reducing stranded power within their data halls, and then using throttling techniques so that they could push up to 98% of the breaker limits that they had within the data hall, so that they're giving every watt that they had available to the services. Now, in terms of those throttling characteristics, not all of the various business types were able to utilize throttling because there is an impact to the users of the services that are throttled. And so for the larger hyperscale ones where they had more buffers within their systems and they could handle that impact to the users themselves when services are throttled, it was fine for them to do it. But for smaller organizations where any impact to the services is immediately felt by the users and there was no buffer to accommodate it, they couldn't actually implement the throttling techniques. So there was a lot of discussion around how are the techniques deployed? How do they choose which services are throttled? How are the users impacted? What does that look and feel like for the users? We also did a lot of discussion around COVID, supply chain issues, how it's impacting our ability to build data centers and get that capacity that we needed, labor shortages that we're having, really a lot of common trends that we've seen year over year in the data center industry just came up, but it seems to be enhanced right now because of the COVID issues, the requirements of the different internet infrastructure items that we support, so there's just additional demand on that. We also spent a little bit of time talking about robotics and AI within the infrastructure segment of it. Robotics didn't seem to be used that much. I mean, it's used a little bit, but it wasn't to the point where we're pulling power supplies and replacing power supplies with the robotics. It was more going around and reading sensors or just identifying status of equipment. We weren't using AI in terms of managing the infrastructure. So I think that's an area of growth that we could use is starting to implement AI and looking at how the buildings are responding to different environmental conditions and getting those control systems to automatically respond to it, and more than just automatic, right? I mean, to use that AI information to predict where it should be going with the information coming in, because all the systems are automated, right? I don't want to go there, but that technology isn't really being implemented into our infrastructure yet.
And that's you said a couple very interesting things in there. That was a debate like you're saying, the density element of some people are seeing that like the 20 kilowatts, and then you got to say, well, I'm rolling these really dense ones out. I've got NVIDIA clusters, and those clusters are drawing 45 kilowatts a cabinet, right? Because they're packing them in. But like you said, it's a smaller percentage. And so really the key that we're looking at is if we look at our whole portfolio, how much of that is going to be super dense, right? And I'm not talking extreme dense. This isn't the 100 kilowatts per cabinet kind of thing. This is the 50 kilowatt range that you have with a lot of this machine learning and AI. And it definitely exists, but the prediction, or at least from what we agreed upon, is it's going to be less than 10% of the portfolio. It's going to consume 5 times the amount of power, but it's going to be less than 10% of the overall portfolio. And so, and then that same thing with the cooling aspect. When do you need liquid cooling? So there's less liquid cooling. It's still needed, but there's a perfect workload for it for less than 10% of the portfolio.
Correct.
So then what does that mean, when it comes down to how you approach design? And one thing that you made me remember is that there was a debate between being able to interweave density and lower density, right? And I think you guys have solved a lot of that within your own infrastructure versus others that are saying, I have to have, like my data centers can't handle that density. I have to build a whole nother chunk, like a dedicated thing for this 10% of the portfolio. Totally different design with what that looks like. And so again, we've got opposing opinions and approaches, which is great because in the end of it, everybody's thinking about different ways to solve it. And that's going to bring out good trends. But what, I guess, give me your perspective on what you think, take the next 5 years. You talked about the average is in this less than 20 kilowatt when it comes to density, but we're still in the 8 to 13 kilowatts, right? And
Correct.
still, and it depends on maturity of companies, but from an average standpoint, that's not a lot bigger than we had 10 years ago. We're in the 5 to 10 kilowatts. Now we're kind of in the 8 to 13 kilowatts on average when you think of the full portfolio. But what do you believe the future is going to be from a density standpoint for the other part of the portfolio?
Right. I think the other part of the portfolio, it's going to grow, but in terms of density, it's going to grow, but it's going to grow at a very slow pace, right? And I do think that we're also going to see the denser racks grow in quantities, right? I do think they're going to slowly become a larger portion of the portfolio as we, learn what it's capable of doing and learn to use those services. But I don't think we're going to see this massive change going from an average of 10 kW a rack to an average of 20 kW a rack in 2 years. I don't see that happening. I think the growth is going to be very slow. It's going to take time. In 5 years, I don't expect us to be significantly different than where we are today.
Gotcha. And history kind of supports what you're talking about. If you take the last 10 to 15 years, it's been a pretty gradual climb when it comes down to average density across the data center. Nuances in corner cases, et cetera, but pretty consistent there. And then, and Kate, I'm going to go to you next, but Kurt, specifically for you on this, do you think that the storage side is part of that reason that those predictions, because storage as far as density is lower?
Yeah, I'm sorry. Which predictions are you talking? I think the storage will
steady growth
continue to be lower on the power end, but yeah, the density will continue to increase. I mean, we're seeing hard drive densities that have a good chance at going up significantly, I think, over the next 10 years. But yeah, I think from a power standpoint, it's not going to be the biggest power drawer in the data center.
Okay. All right. Excellent. Well, thank you so far. Let's weave this all together now. Infrastructure management, Mr. Khatri. So give us your insights there and feel free to comment on the elements that we've been talking about.
Sounds good. I think we've hit a lot of the commonalities between the different tracks as we talk more about infrastructure management, just as you started with earlier. Our discussion at points was almost rapid fire of things that are top of mind for folks. But so Wendy and I were able to at least coalesce it into sort of 3 major themes. And what we came up with as one theme was all around people. A second theme was the cloud and migration to the cloud. And then last, but obviously not least, is on-prem infrastructure itself. And so as we dived into like just people itself, like we've talked a bit earlier about labor disruptions and changes to skill sets. It is tough to get good talent. I mean, like that is something we're seeing right now across the board. Many folks that attended kind of echoed that same sentiment. You know, most of the top talent ends up having a desire to want to go to the top, or what are perceived as the top companies inside of the Bay Area. You know, companies that are doing next gen stuff. You know, startups are always really exciting for folks to gravitate towards, and so there's still that trend of seeing sort of a lot of talent still gravitate that way. And then as we talked, we shifted a little bit and just spoke a little bit about macro level challenges as it disrupts people, like especially during the pandemic. One of the things that was called out by one of the panelists was what we're seeing is this sort of inequity in the overall ecosystem itself. And if we take a look at some SMBs, like small business owners themselves during the pandemic, you know, technology was not necessarily their friend directly, but by leveraging larger companies, they're able to have access to technology and thus have business continuity. But they were sort of at the mercy of some of the large tech players that were able to bring services to them versus them be able to just leverage it themselves. So that whole notion of sort of low to no code isn't as readily available to someone who isn't necessarily involved in technology on a regular basis. And so that gap continues to be there. And then continuing down the lines of just people discussions and sort of, we hit a topic of decision making, right? Look in any enterprise. And we talked a lot about decision making in various contexts, but this one kind of manifested from talking about like what drives migrations to the cloud? Who makes these decisions? Like, how are they made? You know, do we get good transparency of a lot of the whys? Like, why are we doing this? What are we looking to achieve? What are those KPIs we're measuring? Like, they don't always sort of cascade down from the executive boardroom per se as those decisions are made. And we talked about how that was an opportunity to sort of help folks that are helping to make the migration to better understand it in those cases where it is there. And then that kind of drove us to talk a lot more into the cloud itself, right? And there's this constant debate between, you know, do we move to, you know, public cloud? Do we stay private? Like, do we manage our own data centers? Where does that make sense? And why should we do it? And that was that whole notion of, well, generally we feel like it's top down, but who at the top? And, you know, we had folks in the discussion who were in those discussions. And, you know, that the interesting part about that is, you know, generally those discussions are not ill-informed. They're all informed with lots of data that drives the discussion, generally TCOs, you know, strategic initiatives. There's input that goes in. It's just not that it translates down to the desk very well all the time. And so there's lots of different.
And you were saying they were making decisions based on the information they had.
That's right. The information that they have at the time.
Right.
And that changes over time, right? Like, you just think of cost of running on-prem infrastructure can change over time, right? And decrease, which will then re-inform that decision. Like, and this is why it's a constant debate. It's just not something that's steady because that equation changes often.
Mm-hmm.
So that was definitely interesting. We talked about different models as well, right? Do you go all cloud? Do you go hybrid? Do you stay on-prem? And when does that make sense? Because I think a lot of us know at a certain scale, on-prem is definitely, from a TCO perspective, just difficult to match, right? Because you have lots of levers that you can pull when it comes to on-prem infrastructure at scale. And as you mentioned earlier, hardware costs are like 60% of it. And a solid hardware engineering team can continue to bring those costs down, right? And that continues to give you that advantage. And you can get different profiles of hardware that gives you better performance. Like, it's not only cost that drives that. But when it came to that discussion, it was all about, like, why are we doing it? Like, what are we trying to achieve, and making sure that we document that well. And then we dug into lots of different cloud topics, from like reliability, infrastructure as code, the impact on technology. And again, it came back to people. Like, moving to the cloud requires a different set of skills than to manage and run in the cloud. And so what does that do to your sort of typical infrastructure team? So then, do you have transferable skills? Which ones are those? How do you get training? Do you provide like retraining? And again, back to that decision-making process, if it's not done with a degree of transparency on where you are, where you want to be, you lose critical workforce folks. Like, people tend to, see or make decisions without being informed or without having all the information at hand. And so thus you start losing, critical folks on your team for a perspective of looking like you're indecisive. And so that was, that definitely is something many of us have seen in the industry as well. And as we shifted out of the cloud and just talked a lot more about on-prem, lots of topics here, but the one that many of us have already touched on earlier is the supply chain disruptions. We're all seeing it, and I'd love to say it feels like it's getting better, but just as you think it's getting better, you hear about the number of ships sitting on the ports of Long Beach growing, and supply chain issues continuing to change. Like when initially we saw it with like ICs and excuse me, little puppy. We saw it with ICs, it translated into hardware impacts, then it impacted us on network gear. We're seeing it now on builds associated with like, busway and all that. All those components have to traverse through some supply chain, and we're seeing those impacts. And then last but not least, folks who actually do the work, right? Electricians, et cetera. Those are now starting to disrupt the overall process itself. Most current thing I heard there is a shortage now brewing in glass and plastic. So we'll see how that manifests into the supply chain issues. But yeah, supply chain was definitely a big topic. And then we also talked about AI, ML, a little bit that you touched there on, like, density and, being able to cool more dense sort of deployments. Though granted, there was a little debate there that I thought was slightly comical, or, it came out and said, why not just pack less cores and not go dense so we don't need liquid cooling? And then obviously sustainability, and then a little bit on quantum computing was talked about as well, and sort of how unprepared many of us felt to be able to embrace that when it hits.
Yep. And what's great is in the chat right now, there's a debate going on about density itself. And that's exactly it, is that we've got people with different perspectives that actually have deployments and portfolios that are different than others. And it's great. I want to pull two things out from what you said. Supply chain, again, hit everybody, and also in the partner track. So I'm just going to give a few quick things about the partner track. They're seeing lead times up to 52 months. Like, it's insane when it comes down to just trying to get physical infrastructure to build capacity to be able to serve the different customers. So, and also it was around these, they even use the weight of their brands to go back and influence their suppliers to be able to get prioritization when it comes down to delivery. And so, again, it's hard. And this all, somebody who's doing a 50 megawatt data center is suddenly little because they just did a gigawatt order of generators and everything else, right? And then their lead times went from 18 weeks to 32 to 52. Like I said, and they just, what are they going to do, right? As they're trying to do it. So everybody's fighting for that capacity. But the other thing that came up in there was working under scarcity. We have an issue right now. And what we heard, I think, Kurt, on your track as well, is that roadmaps are being impacted based on, I think I'm just going to skip this chipset because I can't get it for a year. I'm just going to go to the next, right? And so they're doing that.
I think it was a combination of that and the just maddening pace at which some of these things are starting to spin out and be released. And so it's causing, like you just said, it's causing people to have to make choices.
Mm-hmm. So that's, and I want to open this up to a few questions on there. So folks, that if you haven't throw up into the chat, we're going to have a few minutes for that. We've got about 7 minutes left in this panel. But two other things that came out in the sessions with the partner track, which I thought was really got me thinking, was the embedded carbon aspects. So, and a sustainability sticker. So think about it, when you go to a restaurant, you open up and you can see the nutrition now about what you're buying, ordering, and eating, right? Then you think about what you do in the grocery store, and there's a nutrition sticker on there that breaks down the sodium and all the other elements of it. What they were thinking is, we've got to go work with the suppliers to be able to have, I just got this unit deployed to my data center. Doesn't care what it is, generator, rack, whatever else. If you put a sustainability sticker on there to understand the embedded carbon of that thing, you can calculate what the actual embedded carbon is of your deployments. And right now we have nothing like that. It's a tough problem to do, but I thought it was really, really insightful, a simple way to go back and say, great, take all of the different suppliers and data centers and say, we require a sustainability sticker. Because here's what was interesting. Somebody ordered a generator, but that generator had to have parts flown in from all these other places. It was assembled in one thing, then it was shipped over to another place, and it was tested right in another. Then it was shipped to a holding factory. Then it was shipped, like it's shipped 5 times to be able to get to a certain place. So there's a shipment element of it, but then there's the components that are in it, right? And there's manufacturing process. And what is the true embedded footprint, right? Embedded carbon footprint of that thing. And that is a really interesting way. That sticker, I think we should consider, because that's something like our industry group could go back and drive. So really it's working under constraints and what we do with the supply chain issues, and then really about the sustainability from an embedded carbon standpoint, the sticker side. 2 big things that came out. So I don't know if you guys have any comments on those at all, but if not, I'm going to go to the questions. Okay. All right. So again, there's been debates back and forth here on the density side. So Yuval, I love it. He was one of the co-chairs within there. I think he's saying high power racks will require, especially around the edge. Great, combined with next generation technology. So I think the question in all this is, we're talking about core data centers, but we haven't even talked about the edge itself. And when you think about my intro with 7 million data centers, with edge being all the way down to some little 10 kilowatt rack or 5 kilowatt rack sitting on the side of a street, it's edge, right? It's doing processing of digital services at that edge point. How many of those are going to be distributed around to support smart cities, et cetera? So we could have another order of magnitude bigger locations. And then each of those, what's going to be required? And usually power is more expensive. Capacity is harder to get, right? It's constrained in different ways within those edge deployments. So there's a lot of things that we need to think about around that side. Any thoughts on edge from your perspective and your definition of edge for the panelists? No thoughts.
I can go ahead, because a lot of the edge network is kind of like a hot topic here as well. I think definitely edge computing is something a lot of industry companies are investigating, how to move the right compute workload, and even more than that, closer to the users. So I think in a lot of sense, the edge is becoming more and more like disaggregate, a key in the disaggregated internet. A lot of people call that. But to be honest, I don't think that a lot of the industry companies has seen like a fast movement of all moving to the edge to build the core of internet. And it's still one important component alongside with the core data centers that we'll be hosting.
Okay. Other thoughts on edge? Anybody playing around with edge in that side? Okay, so let me give a little perspective as well. I think that we are kind of in the pre-definition, right? Pre-deployment, and it's a little bit of the Wild West. Nobody's really defined exactly what is edge. Okay, well, like I just said, there's this thing on the street corner. Is a wiring closet in a building? Is a 5G tower? Is it like all of these elements have to be defined? But in the end, we know things are moving closer in the latency elements, and there's certain applications. This weekend, I had a pretty intense debate because somebody was coming back and saying, tell me the application. Who's going to use it? Who needs less than 1 millisecond latency? Who? What company? What have they signed up? What, so it's a chicken and egg right now. And so I think that edge is that brave new world that we're all looking at. It's just like cloud. Who would need cloud back in the day? I could build my own. I could do that. Why would I go to cloud? Now think about edge. What happens when you suddenly have low latency performance compute that's 100 feet from you? How would you use it? So somebody threw in here a little boon for the rec industry. This working under constraints right now. Recycled equipment, circular economy equipment is actually happening because commodities that are inside of these retired servers, are available, and they are now going for a premium because you can't actually get memory, CPUs, NICs, and other aspects new. So there's a whole circular economy thing here. It's got a boom that's going to happen. I totally agree with that statement. Okay. All right. So just really quick, any last closing thoughts or things we might have missed within the panel? And we're going to go into our fun little magic show.
Nothing here.
Okay. All right. Well, hey, thanks. And we could have talked for 3 more hours because I know how much content was in each of your tracks, and I because I was there. It's really, really good stuff. Before we jump into the magic show, we're going to do a quick poll for this. Adrian, if you could throw that back up for everybody. Okay, this is about growth. You just heard all these different things. What kind of growth do you predict in the industry over the next 5 to 10 years or 5 years? And then what do you believe is going to be the growth in the next 10 years? By the way, this is capacity growth. Okay, how much growth from what we have today in the next 5 years and in the next 10 years? So take just a second to do that. Okay. And as a panelist, I can't vote. All right. Adrian, we got enough to show? All right, over the next 5 years, we have over half the people that believe it's going to be up to 50% or more than double. But 31% believe it's 3 to 5 times what we have today. And over the next 10 years, the majority are 2 to 5 times what we have today. But there's 35% that believe it's even higher than that, 6 to 20x. Okay, just so you know, we've had 100x growth when you think about the decade we did before. Interesting, and Edge isn't even there yet. All right, awesome. Well, thank you very much again for being on the panel. I really appreciate it. And do me a favor, smile. I'm taking a screenshot. All right, awesome. Okay, we're going to move into our next section. Deborah, I think you're going to stay with us on this. Yes. Okay.
Yes.
Okay, we're going to introduce Shimshi. He is a magician that I've watched perform a number of times, and he did it through Zoom. I have no idea. The guy blows my mind every time he does this. So again, for those that are participating, pull out your cards, and Shimshi is going to help us understand exactly what this is. But for the next 22 minutes, let's see exactly how much amazement we can have. Okay. Great. There he is, half of him, Shimshi. Wonderful. All right, Deborah. And by the way, for the folks that are watching, I really encourage you to stay on for this. It's really interesting. And then we've got a few folks that are jumping on from around the world. They're going to participate directly in Shimshi's show here. So as they come in, Shimshi, we'll go ahead and get started. Okay, I think we've lost. Adrian, are we able to promote the other panelists?
They're coming.
They're coming. All right. Okay, so I'm gonna start with a dad joke. No, I'm not. Pick a card, any card. I'm here in Virginia, and last night I'm like, oh man, I don't have a deck of cards. So I went out to Walmart and found one. So excellent. All right, Liz, Joshua, Stella. We got folks coming in from all over the world. Liz, you're in London?
Yeah, near London. Yeah.
Near London, okay. Josh, where are you at?
Singapore.
In Singapore, okay. Stella, I think you're in my
Paris.
favorite city. In Paris, you're in my favorite
Yes.
city. Okay, one of my favorite cities, yes. Okay, and Deborah, we're in Oakland, right? It's still a good city. It's not Paris, but it's a good
It's not
city.
Paris, no. No.
Excellent. Okay, do we have Shimshi on?
Are you watching me now?
Yeah.
Because I fell in love with a magician over in Las Vegas. We did our show.
You fell in love with a magician?
Well,
This is news. Does Joy know about this?
the guy's name is Shimshi.
A guy?
It's Shimshi, everybody.
He's performed for for Michael Jackson, Robert De Niro, Steven Spielberg, and is the resident magician at the Wynn in Las Vegas. Our next guest is the resident magician at the Wynn Hotel in Las Vegas. Today, he's here to show us his goods. You heard me. Please welcome Shimshi.
Hey!
Hello. Thank you, guys. Thank you. Thank you so much for having me, everybody. I'm going to kick things off right away with my opener. This is my opener. See? It's an opener. Now that we have an opener, we need something to open.
Hey, all right.
Nice.
Good morning, everybody. Drink, anybody?
It's
No?
5 o'clock somewhere, man. It's good.
Yes, it is. Well, thank you guys so much for having me. Thank you, everybody, for joining us. We have an amazing panelist. People here with us. Let's see who should. Joshua, how you doing, Joshua?
Good. And yourself?
Good. And Taylor came over. Hi, Taylor.
Hi.
So this is how we used to do it. We used to make things appear, with pocket handkerchief, but it all went digital right now. So Taylor, you're gonna help me choose a drink at random. I just Google image the word cocktails.
Okay.
Hey. So we're gonna choose one at random. I'm just going to scroll like this.
Okay.
Close my eyes and just say stop whenever you feel like it.
Okay. Stop.
Right here.
Mm-hmm.
Okay.
Yes.
Which one do you want?
The blue one.
The blue one. All right. It's hard to see. Let's click on it. This one says Blue Lagoon cocktail. Yes.
Yeah.
If I zoom in, you could have chosen any drink you wanted. All I have to do is reach inside the iPad and pull one drink out.
Okay. Look, everybody.
It's even gone here.
No way. No
Yeah.
way.
Okay. We did not stage this. Seriously, everybody that's on here.
I just know Taylor. She always likes the Blue Lagoon cocktail. But no, thank you. Cheers, everybody. If it's early enough, I don't know.
Cheers.
Everybody, water. All right, fine. I'll turn this one into Gatorade. All right. Good morning. Where are you from, Taylor?
I'm from Colorado, but I'm currently in London, so it is 5 o'clock here.
Oh wow. Okay, so this could have been a drink. And
Yeah.
what do you do? What do you do?
I just joined iMasons as the marketing and communications lead.
Okay, sounds good. This is good. So here's the amazing part. I'm going to take this drink. I'm going to pull it right through the camera and grab it for me.
Okay.
No, one day it will work. We should have prearranged this. That would have been amazing if we prearranged it. But this is the most challenging things, right? Is to do magic through the internet. It's very important that it is authentic. We didn't prearrange anything, and it's also even harder doing magic through the internet, right? Because nobody can pick a card or do something. So I became a little bit creative about this since you can't take one out. Here's what I did. I drew on the back of the cards, and I did this in the beginning of the pandemic. As you can tell, I had a lot of time. And what I did was I drew on every single card. It really took me a long time, but I do it a little bit differently. As you can tell, his hand is a little bit different here, right? And then it gradually something happens, but I don't want to tell you what happens just yet because it is, it's unbelievable, the suspense in the end. Joshua, you are going to just say stop whenever you feel like it. Just whenever you feel like it.
Stop.
Right here? 6 of hearts? You don't seem happy about it. You can choose another one. That's fine.
No, that's good.
No, you don't have to be nice to me. You can choose a different one. I want it to be authentic. I don't want you. He didn't seem happy, did he?
He didn't.
He didn't. Just name any card you wanted, Joshua. Just name one.
Okay. 6 of spades.
6 of spades. That's so
Just not
close
hearts.
to 6 of hearts. Are you sure? It's like very. Okay. Are you sure you want the 6 of spades?
That's right.
You don't want to change your mind.
No.
You don't want maybe the 8 of hearts?
No, I'll stick with
No,
it.
6 of spades. All right, that's okay. That's okay. It's really interesting. This is the story that I drew down. If I riffle through the cards, you can actually see, this is me, by the way, when I was young, I used to be skinny. I'm reaching behind the curtain, and behind the curtain, there is one big card, and that card is none other than the 6 of Hearts. But you didn't like the 6 of Hearts. You were like, yeah, I don't want the 6 of Hearts. So in the drawing, I'm actually dropping it because I do have one more thing inside my hat. Looks like a rabbit, but it's not. This is a big card, none other than the card you just named, the 6 of Spades.
Oh my gosh.
No
Instant
friggin' way.
replay, instant replay. Take a look, take a look. Oh, 6 of Hearts. No, I don't want the 6 of Hearts. I want the 6 of Spades.
Joshua, did you tell him?
No. Can you teach
Come
me
on,
the
guys, you know this already. I'm gonna pick on all of you so you know there's nothing prearranged. By the way, thank you so much, Joshua, for choosing that one. Otherwise, I would have sucked so bad. So I really appreciate it. I've actually tried it like 51 times, and this is the first time that it worked. So thank you. Even though odds-wise it's actually more than 2,500, but we're gonna escalate this. It's gonna get bigger and bigger and more difficult. And I'm going to try to read some minds, but I thought it would be fun to do something with everybody. So we asked everybody to bring cards with them. All you need is 4 cards. So grab 4 cards out of your deck. Make sure they're all different. Grab 4 cards and make sure these are paper cards because we are going to ruin them. I know a lot of you guys, I can't see you, but if you do have cards, grab them. This is going to be one of the most amazing things you've ever seen. Now, this is very important. This is not me doing the magic through the computer. This following thing is going to be you doing the magic yourself. So the more carefully you listen to the instructions, the more accurate you are with everything that I'm saying, the more chances for this to work, okay? And it will work if you follow my instructions exactly. So do exactly what I'm doing. Everybody grab the cards and first give them a little mix. Just give them a little mix so you don't know what the order is. I don't know what the order is. Give them a little mix. Perfect. And then you're going to hold them like this, and we're going to bend them this way. Okay, so however is comfortable for you, bend all the cards together just like that. Yeah, get a good bend on it. In fact, after you bend it this way, turn it the other way and bend it the other way, because we are going to tear them off, so this makes it a lot easier. So press good and hard on it. Don't get ahead of me, just do this, go kind of back and forth a few times. And when you're done, hold them just like this. Perfect. We'll do it all together. Everybody grab the cards like this and slowly tear them off so you have one pile in each hand. Keep one pile in each hand. Perfect. And now you're going to take one pile and you're going to put over the other. Doesn't matter which one goes over the other, you decide. One pile, a whole pile goes over the other, and square them off just like this. Everybody's good? Say yes?
Yes.
Yes.
Perfect. Now, everybody take the first piece from the top, the very first piece from the top, make sure you only have one, and put it all the way to the bottom, all the way to the bottom. First piece from the top, all the way to the bottom. Everybody done that?
Bottom.
Say yes?
Yep.
Yes.
Good. Liz is very intense. She's listening carefully. I like that. All right. Now, everybody take the next 2 pieces from the top, the next 2 pieces from the top. 1, 2, make sure you have exactly 2. Put those all the way to the bottom, all the way to the bottom. Everybody done that? Say yes?
Yes.
Yes.
Perfect. Take the next piece from the top. Don't put it on the bottom, but this piece you're going to put in your pocket. If you don't have a pocket, tuck it in somewhere, sit on it, put under your leg, make sure it's safe. This is your secret piece card. We're going to get to that later. All right, moving on. Everybody take the next 2 pieces from the top. Next 2 pieces from the top. 1, 2, good. And put it all the way at the bottom. Excellent. Now we're going to do something a little bit different. Everybody take the next piece from the top, and put it somewhere in the middle. So some of you can put it dead center. Some of you can put it second from the top, close to the bottom, which means that now it's getting a little interesting because everybody's cards are mixed a little bit different, right? But we're going to take it to the next level. Everybody take the very first piece and count it down onto the table. First piece, count it down onto the table.
Mm-hmm.
Good.
1.
Now everybody takes the very next piece from the top and count it down on top of the card you have already counted. On top of the card you already counted. Not next to it, not around it, right on top of the card you already counted. Now, here's the interesting thing. Some of you guys can stop right here, which means we only counted 2 cards, right? Some of you guys can count 3, can count 4, can count 5. It doesn't even have to be from the top. It can be from the middle. So let's say I'm going to take one more card from the middle. I'm going to put that on the top, and I'm going to stop at 3 cards. So that gives us a really random thing from everybody. So some of you count 3, 4. You can count all the cards if you want. Hopefully by now, everybody made their decision.
Mm-hmm.
Perfect. If you have some cards left in your hand, you can give them a little bit more mix and then put those on top of the pile you have already counted. On top of the pile you've already counted.
On top. Yep.
And then, yeah, and then you're going to grab everything all in one. Perfect. So this got complicated on purpose because the more complicated it is, the more shuffle it is, the more random it is for everybody. And I was trying to see if we can all find the connection right now. Okay. Would you agree all the cards are mixed completely differently for everybody? We're all going to try to find the connection right now. So everybody take the first 2 pieces from the top, and throw them away. Toss them away. Joshua, don't place them neatly. You got to throw them away. It's very liberating. It's very neat. I like that. All right. Now everybody take the next 3 pieces from the top. 1, 2, 3. 3 pieces from the top. And throw those away. He still puts it neatly. I like that. So everybody should have left 2 different pieces. Everybody should have left 2 different pieces. We're going to have somebody decide for everybody. Stella, can you unmute yourself for a second? Stella, you're going to decide for everybody now. Should the next piece be the top or the bottom?
The bottom.
Are you sure? This is the most important part for everybody. You want everybody to have the bottom, not the top?
Yes.
Okay. So everybody throw the top piece away. Throw the top piece away. It could have been this card, but she won with the bottom card. So everybody hold on to the bottom with dear life. Take a look at what you have. Now reach into your pocket. Remember that card that we shuffled in the beginning and see if you have.
Holy crap.
Oh my goodness.
Perfect match. There you go. 1, 2, 3.
No.
Crazy. Oh my
Look at that.
That's wild. Mine aren't even real cards
I'm
anymore.
applauding you guys. This is incredible.
More claps than one. More claps.
Stella. I mean, we all mixed it up, but think about it. If we would have kept the top card, it wouldn't have worked. Now, I know there's a lot of you guys over there. Maybe you guys are, maybe recording this. So if you didn't have cards this time, you can watch the recording and do the exact same thing we said, as long as you listen to Stella and you stay with the bottom card in the end. So thank you, Stella. Thank you guys very much.
Good job, Stella.
It's still amazing. I still don't know how this one works, to be honest with you myself, but you know, I'm very, very happy. So I wanted to show you one of my favorite illusions. This I used to do since I was about, I don't know, 12 years old. This is one of the first magic I showed to my mom and dad, actually. So Dean, do you mind playing my dad?
Yes.
Yes.
Go ahead, son.
Is it okay if I call you dad?
Feel free, son. Yes.
Oh, that's weird. No, I'll just call you Dean. Dean. By the way, do you want to watch it? I'm originally from Israel, and do you want to watch it in my Israeli accent or American accent? Up to you.
Israeli.
Israeli, no problem. I do it for you. Very, very easy.
Awesome.
Okay. Yes. This is actually my real accent when I talk like this. It's really easy for me. I try to be professional, you know, when I do shows and stuff. But anyways, this is what I did for my mom and dad. I have here an empty bag, nothing inside the bag, nothing in my hand. Yes?
Yes.
I want you to tell me one number between 1 and 5. One number between 1 and 5.
4.
4. Watch.
Wow.
Thank you. You're actually a lot more kind than my dad. He was not impressed, but I told him, no, this is not the magic trick. This is just the beginning. This was just like the warm up, the joke.
I Kervolt. Is that right?
No one let me drink. Say that again?
I Kervolt. Is that correct? No? I don't know.
Yeah. Oh, Kervolt? No, that's Yiddish. No, this is
Yiddish?
ancient
Okay, I have
Hebrew.
no idea.
I'm not familiar with that. But this is what I showed them. I said, I'm going to make this Coke disappear. They wouldn't let me drink a lot of soda, so I took this advantage and opportunity. And I was like, Supposed to go, but that's
Go,
okay.
go. Yep. Okay.
No, this is what I did. I said, look, I'm going to take the bottle. I put it inside the bag. I snap my fingers and the bottle is gone. I snap one more time and it's back. Okay, this is how I used to do it when I was 13 years old, but by the time I was about 15, I actually mastered this illusion. Watch. You know what? I'm kind of old for this right now. I don't want to do it. It's a silly trick. We're going to do the good stuff right now, okay? We're going to do the good stuff for everybody. So let's see, who should we bring in next?
Nicely done, son.
Haven't we had? We've kind of had all of you. Deborah, how you doing, Deborah?
Doing great, thank you. And you?
Can we co-spotlight Deborah with me? Deborah, we're going to try something with this Rubik's Cube. Have you ever able to solve a Rubik's Cube?
I was years ago, yeah.
Really? That's amazing. So when they first came out, I remember that almost nobody could solve these. It was considered impossible. Now you have a lot of kids on the internet solving it, you know, under 10 seconds, which is pretty crazy. So I do think our brain is evolving all the time, and it's really amazing. And I heard an inspiring quote from Albert Einstein. He said that imagination is more important than knowledge. So I figured I'll solve this in a creative way. Okay, so I'm going to take this Rubik's Cube and I'm going to put it in a clear bag so you can see it all the way around. And I'm just going to try to imagine it solving itself, just my imagination. And then you can see it is solved.
Holy smokes.
I know. Now, if you were here, you'll be able to check. This is a regular Rubik's Cube. There's nothing tricky about it. I let people check it all the time, but we're going to try to do something challenging, Deborah. I'm going to have you help me mix it up, okay? So the first thing we're going to do is I'm going to mix it up. I'm going to close my eyes, and you're just going to say stop. Whenever you feel like it, that would be stage one.
Stop.
Right here?
Yeah.
Okay, that's stage one. Maybe I still could manipulate it somehow, right? So you're going to tell me exactly how to mix it up. One thing to know about the Rubik's Cube, if you guys didn't know, the middles never change. That's one of the techniques to solve it, right? The middle always stay the same. So what would you like to face you? Which color? Green, blue, white, yellow, orange, or red?
The blue.
The blue facing you. Perfect. Here's what we're going to do. You're going to tell me, for instance, turn right side 1 time or left side 2 times. Okay. You have the right, left. We'll make it my right so it's easier. Right, left, front, top, bottom. At any point you want to change to a different color to be facing you, that the middle, that is, you just let me know. Okay, go ahead. Don't even think about it. Just go random. So it's really random.
Turn the top twice.
1, 2.
And right once. Left once. Let's go green facing me.
Green facing you?
Yeah, let's go bottom once.
Bottom once. By the way, I have this cube that I've worked on for 2 weeks. For 2 weeks, I've been working on this one. Any idea, Deborah, how many ways there are to mix up the cube? Give me your wildest guess. Whatever you think it is, go times 1,000,000. I'm not kidding. Give me a guess. Whatever you think it is, times 1,000,000.
Oh, I don't know, 1 trillion times 1,000,000.
Which is how much?
Oh, I can't do math on a show. Are you kidding me?
They're actually, I'm not good at math either. I just Googled it. There are 43 quintillion ways to mix up the cube. That's 1,000,000 times 1,000,000. 43 quintillion ways to mix up the cube. Up to 5 more times you can mix it. You don't have to use them all, but up to 5 more times. Which color towards you, and how do you want me to turn it?
Let's go right 2.
Keep it this way, green towards you?
Yep, right
1,
2,
2.
left 2.
Left 2.
Let's go red towards me.
Red towards you.
Top 2.
1, 2.
And let's go white towards me. Right 1.
Okay, you really made it complicated.
Good.
That's it?
That's it, yeah.
Or one more?
Okay, let's go orange towards
Don't
me.
let me influence you.
You already
Orange
did.
towards you?
Orange towards me.
Orange towards you.
And let's
One last
go
one.
left one.
Left one.
Yeah.
Incredible. This is incredible. Look at this blue line right over here. This is incredible because I was not trying to solve this. I told you I've been working on this for 2 weeks. I actually was trying to guess how exactly you're going to mix it up. One of those 43 quintillion permutations. Can you see how this side matches exactly?
Holy smokes.
Exactly, not just one side, two sides matches absolutely perfectly.
That's incredible.
I know, this is three ways exactly matches perfectly. This is 4 ways up and down all the way around, 43 quintillion ways completely perfectly matched.
That's insane.
Give Deborah a big round of
Stunned.
applause, Deborah.
Good job, Deborah.
Yes. Thank you, Deborah. I
Can you tell me the
appreciate it.
lottery numbers?
I could, yes. We'll talk later, so not everybody wins, you know. All right, Deborah, we can put me in the spotlight so everybody can see this big. Thank you, Deborah. And here's what we're going to do. Just to prove to you that I really knew exactly how she is going to mix it up, I actually studied how to solve this with my eyes closed because I can. So I'm going to try, okay? I'm going to close my eyes. And let's see if I remember. I forgot the beginning. That's not a good sign. All right. I think it's like this. I don't know. Is it getting better or worse? I may have messed it up. I don't know. Does it look like it's getting better or no?
Not so good.
Really?
Not so good, no.
Bear with me. Bear with me. There's only 43 quintillion ways to mix it up. I think actually there's only a few more moves to go.
Really?
Yeah, Dean, what do you think? There's like 4, 5, or 6 moves to go. What do you think?
20.
I'm sorry?
20.
No, you got to choose 4, 5, or 6.
Oh, choose?
Yeah.
4.
4. Exactly 4?
4.
Okay, here's 1. Here's 2. Is it getting closer?
Uh-huh.
Yeah,
Here's 3.
What's going on?
And is this 4?
No way.
Yes, it is.
Oh my gosh.
Oh,
What's going on?
Yep.
Thank you, Dean. Thank you,
Good
Nice.
Dean.
job.
Nice.
I appreciate it. Thank you, thank you, thank you. Whew, can't believe that worked. Can't believe that's not magic. That's just a lot of time on my hand. But actually, I've been traveling a lot and doing a lot of different things. But I want to try something with everybody. I want everybody to think of like a 2-digit number. Make sure that both digits are different. We'll call it like your target number. Okay. Liz, I can tell you already have a target number. Is that right?
Okay.
Yes? You
Yeah.
have a target number? Don't change your mind. Keep it the same target number, whatever it is. You have it?
Yeah.
Okay. No way that I can know which number you have in your mind. Is that correct?
Not that I know of, no.
Before the show started, I wrote something in this envelope.
Stop.
I wrote a number on a big board. For the first time, what is the number that you're thinking of?
It's going to be really embarrassing if it's wrong, though, so I'm worried for you. It's 35.
Don't be worried for me. Just name it. I wrote it down already. What is it?
35.
35. If the number 35 is over here, will you be impressed?
Oh, you're so impressed. Yeah. Is it?
Ladies and gentlemen, 35 is over here. Yes, somewhere over here. Yes, 35. Thank you. See, you don't have to be worried for me. I know what I'm doing. Yes. Thank you. Thank you. Thank you. No. I actually didn't know you're going to choose the number 35. I don't know if you can see 35 is kind of written a little bit differently, right? Yes.
Yeah.
No. This is what I didn't tell you. I wrote this with 2 different markers. Some of it with dry erase and some of it with permanent marker. You said 35. You could have chosen any number. Watch. Oh. Oh.
Oh, stop.
No way.
Oh, stop.
No way.
35, look at this. This
No
is
friggin'
really
way.
on there. That is the only number. 35.
That's crazy.
Thank
What is
you.
going
Now this is
on?
only, thank you. I appreciate it. Oh, I mean, this should be like crazy, right? Yeah, I know. This was insane. Yes, thank you. I know you guys. No, you have to jump. You have to jump. We're actually going to do something better, okay? We're going to try something in the billions. This was just 1 out of 100. So, Deborah, can you search like how many articles are there on Wikipedia? We're going to try something in the billions. And we're going to calculate this so you can see. What I want you to do is, okay, perfect. So there's 6.4 million articles. Last I checked was 6.3. 6.4 million articles times, this also tells you how many words per article they are. What does it say over there? Do you see it?
I think it's 1,603.
1,603. It keeps changing all the time, but basically over 10 billion possibilities, okay? Is there a link to Wikipedia there?
Yeah.
Can you click on the link? It should bring you to like the random article of the day. Can you show us?
Today's featured article.
Okay, perfect. So in the Wikipedia search bar on the top right, I want you to type in any word you want. Type in any word you want, something that you think might have an article about it. So a celebrity is a good idea, a city is a good idea, something in the English dictionary. Type in something and then press search. Let me know if you got something.
Okay.
Did you get an article?
I did.
Perfect. What I want you to do, some of the articles, by the way, have pictures. Some of them don't have pictures. If there is a picture, just got a mental picture in your mind. If there isn't, don't worry about it. But now what I want you to do is to scroll through the article, scroll, and just think of any word you want from inside the article. Very important. Don't click it, don't highlight it, because some people think maybe I can hack your phone. Maybe I installed cameras in your house. So just somewhere from the article, just think of any word. And you know what? Make it like a big word, a few syllables, let's say like 7 letters or more. I'm not sure what you search for, but big word, make it difficult on me. Do you have something in your mind?
Yeah.
You want to change your mind to a different word?
No.
Very important. You didn't click on it, you didn't highlight it, you're just thinking of one word, correct?
Correct.
Perfect. Look into the camera. You can lock the phone, do whatever you want. Look at me. This is the hard part. I want you to think of the first letter. Just think of the first letter. You have the first letter? I'm going to write it down right here. It's not S, is it? No, I think I got it. I'm getting like 3 different letters actually, but okay. I wrote down the first letter. What is the first letter?
C.
What is it?
C, as in cat. C.
C. Really? The first letter of what you searched starts with a C?
No, you told me it was to pick a word. It's not what I searched.
Oh, no, but we'll start with what you searched. What is the first letter of what you searched?
O.
Oh, okay, that's what I wrote down. Oh, you scared me. Okay, let's stay with this word. Let's stay with this word. Think of the second letter. Think of the second letter. Don't say it out loud. Think of the second letter. I wrote it down. What is the second letter of what you searched?
A.
A. I wrote down A. Think of some more letters in the word. Send it to me mentally, not out loud, only in your mind. The reception is actually very good. There's a K there. Is that correct?
Yes.
There's a L also, right?
Correct.
Okay, I think I got it. By the way, did it have a picture?
Yes.
Okay, there's some blue, is that correct? The first thing, like almost half the picture is blue, and then the rest is like white and dark colors.
That's
almost
fair.
like a place, right? So there's like, I see like a sky and a little bit of ocean and buildings. Is that correct?
Correct.
What did you search for the first time?
Oakland, California.
Oakland, California.
Oh,
Now, again, this is what you search for, right? This is not the word you're just thinking of. Think of the word from inside, the one you're just thinking of. Think of the last letter. Think of the last letter. Is the last letter G?
No.
No, you didn't think of California, did you?
I did, yes.
Okay, no. You got to think of something else that has got nothing to do with the article. So go again to the article. Do you see the article?
Yeah.
Yeah, and think of a big word, nothing to do with the article, something random.
Nothing to do with the article.
I mean, something random. So because I already know it's like also in California, so I don't like a random word, a big word though, like 7 letters or more.
Okay.
You have something? You have something? Okay. Okay, I think I got it. It's not a D, is it?
Yes.
It is. Think of the second letter. It's not an I, is it?
Yes.
It is an I. Yes. The last letter doesn't happen to be an H, is it?
Yes.
Billions of possibilities. You're just thinking of one word. That is random and big. Let's hope it works. For the first time, what is the word that you're thinking of?
Distinguish.
Distinguish.
Oh my goodness. Amazing.
Thank you
So
Thank you
good.
guys very much. Thank you.
What is
thank
this
you,
voodoo
thank
that you do?
I appreciate it. All right, our time is almost up. I wanted to show you one last thing. This is has been one of my favorite things to do during the pandemic. I became an influencer. All it means is that I opened a TikTok. That's all it means. But one video did get viral. This is the video. This is me painting with my feet. No magic, just painting with my feet. If you have feet phobia, I apologize. If you like feet, you're welcome. And but doesn't matter. I'm drawing. It looks like it's okay, but then people realize it's upside down. I actually drew The Weekend. Got almost like 30 million views, right? But I did another one especially for you guys today. Okay. Stella, let's try it with you. Stella, I wrote down different celebrities over here. Okay. Different celebrities. And I don't want to show you this 15 different celebrities. I want you to think of a number between 1 and 15, a number between 1 and 15. You have a number between 1 and 15? And by the way, I brought the painting with me. I didn't want you to think that there is, you know, some kind of video trickery or anything. So I'm going to show it to you in a second. Now I'm going to try to influence you to change your mind. Look into my eyes. 1, 2, 3. Change your mind to a different number between 1 and 15. You have a number between 1 and 15? Okay, you didn't change your mind, did you?
No.
You didn't. Okay, 9 is too obvious, just so you know. When I count to 3, try to change your mind to a different number, or if you want to stick with it, you can stick with it. Last time.
Okay.
I don't even want to know if you stuck with the same one or you changed your mind 3 times, but for the first time, I try to influence you. What was the number that you chose?
9.
9. Look, you could have changed your mind. Do you want to change your mind?
No.
Look. You could have thought of Justin Bieber. You could have thought of Robert De Niro, but you changed to, or you chose number 9, which is Jack Black. That's exactly what I try to influence you the entire time. And this is Jack Black.
Oh, skadoosh! Look at that.
Skadoosh.
Skadoosh.
Thank you for letting me get into your minds a little bit. Thank you for sharing the time with me. I really appreciate it. I want to leave you with one last thought. This is my favorite quote from Muhammad Ali, and I wrote it down. He said, don't count the days, but rather make the days count. So let's make it a good one, everybody. Thank you so much. I appreciate it.
Thank you.
And see you next time. Thank you for all our panelists. I appreciate you guys. Thank you. Thank you for making the internet great again and keeping the internet alive. Thank you guys so much.
Awesome. Awesome. Wow. Okay. For everybody that stuck around for that one. So first off, the folks on the panel here that were in that, was that what you expected? Was that insane?
Was amazing.
That was
amazing.
Incredible.
None of that was set up.
Yeah.
No, that's the thing that blows me away. Like no, none of us actually did anything around that. We just showed up. So, wow. Thank you for being on the panel, and thank you for participating within this. We're going to go ahead and close out the summit here. I want to thank everybody in the show, the magic show. I also want to thank Svein, our panelist, and of course Shimshi. And I want to thank everyone here. This has been quite the event. So I want you to mark your calendars for our next event, which is going to be the iMasons Awards ceremony that is going to be on December 15th. And by the way, this was quite the event we had last year. We're taking it to a whole nother level. So we like to put on a good show and make sure that this is fun. Amber Caramella and I are going to be on the stage and doing this awards show for folks all over the world. So we hope that you can join us. We're leveraging a London studio for the latest special effects and also just delivering a visually stunning and memorable live experience to celebrate all the folks that are actually in here doing amazing work. I want to give you one last update. We are raising money for our iMasons Scholarship Fund. And in 2018, we gave out the challenge, the $1 million challenge. Our target was to raise $1 million to help support our next generation of talent in our industry. And half of our scholarships are going to women as well, because we want to increase the diversity when it comes down to it from a gender standpoint, since we have less than 10% females in our industry right now. And that's working well. But before our end user forum, we've raised $568,000 of that target. A lot of it was coming from our fundraiser from last year. And this money is helping students directly across Africa, Europe, the Middle East, APAC, and USA, including a very successful capstone project initiative that's now being ramped out globally. And thank you for your generosity in the User Forum sponsors. Our main event sponsor is Pure Data Centers. And our track partners are Yonder and IT Renew, and they're continuously adding to the fund. We're aiming to raise $700,000 by the end of the awards ceremony on December 15th. So that's our stretch goal we're trying to get to, and anything that you or your companies can help with would be great. It's helping to bring in new talent. We have 5 award categories to give out: education, diversity, inclusion, sustainability, and technology champions, as well as this year's IM 100, and 3 additional additions to the IM luminaries. And don't forget that the award ceremony raises money for the iMason Scholarship Fund itself. And if you'd like to sponsor an award or just make a contribution, that'd be greatly appreciated. Feel free to reach out to Simon Allen or to Jeff Amelchuk, and if you're interested in participating in that one. So with that, as always, thank you to our partners and everybody else that makes our community possible. We would not be here without you. And thank you to all of our members. You guys are awesome, and I'm glad we were able to spend some time together enjoying some magic and learning some more trends that are going out there. So thank you again, and we will see you at the next summit.